Hello, Happy Face Health Club. Okay, so last time we reviewed exponents and polynomials. Today we're going to review factoring, and I wrote our definition that I'm giving on the board. Factoring will be the process of finding polynomials whose product equals a given polynomial. So that's sort of a wordy way of saying you get a polynomial and then you're looking at ways to break that down, and where you have different terms that when multiplied together equal the polynomial you were given. So in this example I've got 4x plus 12, you can pull the 4 out and it's a real number multiplied by x plus 3. So the product of those two terms equals the polynomial that we were given, and that is factored. So we're just going to go through a lot of examples today as a way of getting that habit back, and let's get started. So the first thing we're going to look at is factoring out the greatest common factor. So factoring out GCF, we'll say GCF for the greatest common factor. And the first example, let's get rid of that. First example that I want to give is 9y to the 5th plus y squared. So 9y to the 5th plus y squared. You're looking for what's common in these two terms, and if we, it jumps out pretty quickly that it's y squared, so we can pull y squared out, and then you will get 9y to the 3rd plus 1. So if we remember our exponent rules from the last time, y squared times 9y cubed is 9y to the 5th, and y squared times 1 is y squared, so that works. Alright, next example. We're going to do one that's a little bit longer. 6x squared y cubed plus 9x y to the 4th plus 18 y to the 5th. So this is interesting because you can see that there's actually a common factor in 6, 9, and 18. They're all multiples of 3, and then we've got y's as well. So I think what I'm going to do, and actually this term has no x, so keep that in mind. What I'm going to do is pull out 3y cubed out of each of these. So let's go 3y cubed, and this would become 2x squared. We already pulled the 3y out, plus 3xy plus 6y squared. There you go. The next one is even longer. That's okay, this should be pretty easy. I think this one is good because we can actually do it as a multi-step, sort of a multi-step one. So let's just erase that stuff. So let's see, I'm going to take up more of the board. 14m to the 4th times m plus 1, negative 28 m cubed times m plus 1 minus 7m squared m plus 1. I'll get out of the way so you can see. Okay, so what jumps out as being shared or common in a lot of these, immediately you can see that there's m plus 1 in each one of these, so that's something we can pull out. And then another thing that I'm noticing is that there's 7m squared contained in each of these. So multiples of 7 are all down the line. So let's actually do it as a sort of multi-step one. Just pull out the m plus 1, that's easy. And then multiply this by 14m to the 4th minus 28 m cubed minus 7m squared. So that's slightly more simple, but we can go further. So let's do one other. Let's pull out that 7m squared. M plus 1, we already have 7m squared. We know that's common. And then we have 2m squared minus 4m minus 1. There you go. And that is your sort of final answer. Great. The next thing we're going to look at is factoring by grouping. It's just another technique. Factoring by grouping. Okay, so this is just going to be a general example of a strategy you can follow to factor by grouping. So this is general example. Say you're given ax plus ay plus 6x plus 6y. Let's just put some parentheses around them to show you how to break it up. So first step, ax plus ay. This is just visual recognition at this point. Plus 6x plus 6y. And then, yeah, obviously you can pull the a out of this. A times x plus y. And you can pull a 6 out of here. 6 times x plus y. And then you can combine the like terms. So you can separate that to a, oops, sorry. A plus 6. Oh, I'm writing multiplication. A plus 6 times x plus y. And if you actually want to validate that this is true, we can do the multiplication back so you can FOIL it. So ax plus 6x plus ay plus 6y, and then rearrange ax plus ay plus 6x plus 6y. And that is proof that the technique works. Alright, so that was a general example. Let's do a more specific example. Okay, mp squared plus 7m plus 3p squared plus 21. Loving it. Okay, so let's see. Let's just start off the exact same way. I'm going to draw it on here though. So parentheses. Here, pull out the m, p squared plus 7, plus pull out the 3, p squared plus 7. Oh, that's very nice. And then you can do m plus 3 times p squared plus 7. There's your answer on factoring by grouping. Okay, let's do one more. B. 2y squared plus az minus 2z minus ay squared. Okay. On this one, I think you want to bring together the terms that have like similar coefficients. So let's do this, a little rearranging. So 2y squared minus 2z plus az minus ay squared. That looks like a 9, but this is an a anyway. Okay, so let's pull the 2 out. Y squared minus z. And then to get y squared minus z on here, I'm actually going to have to pull out negative a. So let's do minus a y squared minus z. And then you can see now we can do our grouping. 2 minus a and y squared minus z. There's your answer. Okay, one more for good luck. Okay, so where we left off was this form right here, 2x squared times 2x plus 1 minus 1 times 2x plus 1. Then we can redo our grouping. 2x squared minus 1 times 2x plus 1. There you go. And that works. Okay. Next thing, we are going to go into factoring trinomials, which may be a little bit harder, but factoring trinomials. And we're just going to go straight into examples here, because when you're factoring trinomials, a lot of it is just trying stuff and seeing what works. So you sort of just have to sense it. So let's factor 4y squared minus 11 plus 6. So you know you've got to get these terms when you multiply the factored terms. So let's just start with some ideas. So what if it was 2y, and I know I need 2y over here to get the 4y squared. I know I need a 2 and a 3 to get 6. Let's see if this works. So this would be 4y squared minus 4y minus 6y plus 6. But that actually doesn't work because this is only equal to negative 10, not negative 11. So that doesn't work. Okay. Let's try another idea. Let's try. Okay, what else? How else could we do this? We could do. I have another method. What if we just do 4y right here and y right there, and then we say negative 3 and negative 2. And the reason why I'm choosing negatives here is because I know this middle term has to be negative, but the 6 has to be positive. So whatever is in the spot of these two places has to get me to a positive 6 and a negative, and a negative 11. Okay, so let's try this. So what does that equal? 4y squared minus 3y minus 8y plus 6, and that is equal to 4y squared minus 11y plus 6, so that works. Check. Great. Okay, let's do one more of these. 6p squared minus 7p minus 5. So my initial idea that I tried on this one was 2p minus 5 and 3p plus 1, but this didn't work. So I'm just going to cross that out. So the next idea I tried was 2p plus 1 and 3p minus 5. So you can see, let's see how that goes. That is 6p squared plus 3p minus 10p minus 5. And you can see that's going to work, because that is 6p squared minus 7p minus 5. So, check. You know, I don't necessarily have a good rule for systematically solving, or systematically factoring trinomials. I know there are certain formulas. I sort of tend to just, when they're not perfect squares, which we'll get to next, I just sort of tend to look at it and see what works. But open to suggestions. Okay. Next thing is perfect squares, which are much friendlier. So I'll say factoring perfect squares. And why are these friendly? Because they have a very specific form and you can almost see them immediately. So if you see something that looks like this, I'll give the general form and then we'll do some problems. X squared plus 2xy plus y squared equals x plus y squared. And the or, if you see x squared minus 2xy plus y squared equals x minus y squared, then you know you're dealing with a perfect square and you can just do it you can do it immediately, but it's also good to check. So here's the first example. 16p squared minus 40p q plus 25 q squared. So if you recognize that 16 is 4 squared and 25 is 5 squared, you also know that 4 times 5 is 20, and if you double that, you get 40. So you're dealing with this form right here immediately. And you can simply say that it's equal to 16p minus 5q. That's an ugly q. Whatever. 5q squared. But if you want to really, sorry, stupid mistake. Not 16p, that was silly, was rushing. Okay, 4p, yes, 4 squared is 16. Minus 5q squared. And then if you want to expand that to check, you can just do the math. 4p minus 5q. 4p minus 5q. And that will give you 16p squared minus 20pq minus 20 20pq plus 25q squared. And you can see that that's going to be equal to that up there. So we've proven our case. Okay. Next one. Let's do, it looks big, but it's easy. 169 x squared plus 104 xy squared plus 16y to the fourth. So, looks kind of scary, but it's actually not. Let's just think about what, if you square, what is the square root of 169? It's 13, and the square root of 16 is 4. So you know you're working with something like 13 and 4. So I would propose that this is the answer. 13x plus 4y squared. Let's check it really quickly. 13x plus, 13x plus 4y squared. So 13x plus 4y squared times 13x plus 4y squared equals 169 x squared, yes, plus 52 xy squared plus 52xy squared plus 16y to the fourth. And if you add 52 to 52, that's 104 xy squared. 16y to the fourth, we've got it there. 169x squared, got it there. So we are correct. Great. And where are we now? Oh, we're good. The next thing we're going to get into is factoring differences of squares. Factoring differences of squares. So, I don't think I even have a general form necessarily written out, but you can see third example. It's actually, I think I can come up with a general form for you. So let's just say it's am squared minus b, and that would be, how would you factor that? You can say am plus b. Oh, never mind. I'm confusing myself. Alright, sorry about that pause. Getting back to it, I have a interesting example. It's maybe a little different than what you normally see when you're doing differences of square problems, but let's do it. So it's a plus 2b squared minus 4c squared. And when you first look at this, it doesn't look like a normal difference of squares problem, and it's sort of hard to tell what's going on and how to do it. But the trick is to see this as a square. So if we rewrite it, a plus 2b squared, keep that the same. And then you can rewrite 4c squared as minus 2c squared. And then you can collect the terms into the difference of squares form. So let's do it like this: a plus 2b plus 2, and then a plus 2b minus 2. And then these actually just become the two terms, the big grouping of them. So just rewrite it: a plus 2b plus 2 times a plus 2b minus 2. And if you multiply that out, you will get this answer: left to the diligent student. All right. Last example of the day, we're going to do x squared minus 6x plus 9 minus y to the fourth. So this is an interesting one where it's not very clean either, and you have to sort of figure this one out and get it in the form that you need to do the difference of squares technique. So I see this could be something that could be like y squared squared, but what is going on here? So I think there's an intermediate step where we actually need to factor this right here, and then we'll do the y separately. So let's try x minus 3, x minus 3 squared, and then minus y squared squared. That works. And then we're going to just collect those into our difference of squares like we did last time. So x minus 3 minus y squared times x minus 3 plus y squared, and then that will give us x minus 3 minus y squared all together, and here we've got x minus 3 plus y squared all together. And if you do the expansion of that, you'll see that it equals x squared minus 6x plus 9 minus y to the fourth. So that's the strategy here again, was to split it up, take all your x's and this 9 together, and then take your y separately, and then rewrite it as a square, rewrite this as a square, then bring the y term into your difference of squares, and then you've got the answer. So that has been our factoring review. Thank you for tuning in, and come back for more. Bye.